I'd like to go over the most elegant workbench that I have in my opinion. Sheetmetal does a lot with not very much user interface. I'm very impressed by it. So here we've got a Sheetmetal tray with the flat pattern. So let's get started on making something like this and going over the basic concept of what Sheetmetal is and how to use it. I'm going to start on the part design workbench, and from here I can produce a sketch. When I go to my isometric view, perhaps I'll choose my XZ plane, and I can make something absolutely crazy. In fact, I'll choose a polyline, and of course in Sheetmetal it's quite advisable to use straight lines so that they can be radiused accordingly. So here I've got something pretty insane. When I head over to my Sheetmetal workbench, this is where the magic happens. This is one method in creating a Sheetmetal part, and that is I simply click this button here, create Sheetmetal wall from a sketch, and we've created a Sheetmetal wall from a sketch. In the model, I can highlight base bend. Notice I get a number of parameters that I can change. The first thing is I can change outside to inside and rebuild, and you can see it basically just changes the thickness relative to the sketch. So what side am I putting my thickness? I personally prefer middle, and that makes the sketch that I've made a center line through all the straight portions. And there you have it. The next thing that I can do is, of course, change if I have a different sketch, I can change a link to a different sketch if I want to. I think that you won't use that very often. You can change your length. So, I just made it longer. I can make it shorter. I can enter a custom value if I want to. And of course, I hit the rebuild for the changes to go into effect. I've also noticed Sheetmetal will rebuild when I go to rotate my screen like this. So either rebuild or rotate like that. I can change my radii. If I want to go to 5 thou, make it really tight. That might break. We're going to see. Yeah, 5 thou looks like it's too tight. But I can make it something very large, like 0.5 inches. Again, rebuild, and there goes my very large radius. Looks like, there we go. That updated every radius. 0.5 was too large for everything, but when I made it a size that was realistic, you can see it updates. So I can go 0.125 and rebuild, and so on. Finally, let's say I want to do this in 1/4 inch plate. I can say 0.25 inches, and the plate gets thicker. So that's how we can adjust all the parameters. I would recommend, and the other thing, let's say I want to add a flange on this edge. I can do that by selecting the edge and hovering over here. Extends a wall from a side face of metal sheet. And notice I've created a little flange. Let's say I want that to go the other way. Well, I highlight the bend, and on invert I say true, and now we're going the other direction. I can change my length. Let's say I want that to be 2 inches long, and there you go. And on my radius, let's say I want to have a radius of 0.5 is 500 thou, so there you go. I've adjusted my radius, so you can see every characteristic of this is adjustable from this menu. You also have miter, which you didn't have using the base bend, and if I change auto miter to false, there's a few cool things that I can do. The first thing, I can miter the edges. I can say one at 45, the other at 10, and you can see I'm adding angles here and here as I miter those. Very, very handy feature. And so if I take my length down a little bit, say 0.25, you can see I'm adding what you would think of as a chamfer to these edges, and that's really what mitering is for, more chamfer-like features. The next thing that I can do that would be relevant here is reliefs. We can do reliefs. I think you would come up here and say gap 0.125. Let's say that's kind of a large gap. And you can see we add a gap into here. Let's do something smaller on this side, 0.05. And there's a gap. And then I come into these reliefs, 60 thou. And you'll notice they get deeper with 60 thou. And then the width, I can make 60 thou as well. And they'll get wider. So you can adjust these reliefs and have a gap in here. So that's what those functions are, and that's most of what you have to do for sheet metal. Before I get in too deep, I also want to bring up K-factor. If you're not familiar with K-factor, why this is not a video about K-factor, but to cover it real quick, it covers the stretch that you would get when you bend a piece of metal. That is going to vary depending on what material you use. So it's ostensible that you could look up whatever material you're using and plug in the correct K-factor for that. We default at 0.5. So this is material dependent. Do some homework. There's some equations that you can derive K-factor as well. Finally, you may want to flatten this out, and there's a few ways to do that. One way is I highlight a face, and then I can choose flatten and highlight manual K-factor. ANSI is fine. And there is our flattened piece, including this flattened as well. And that's of course accounting for the stretch that you get when you bend it. So this is what you start with, and as long as your K-factor is right, it's a little bit shorter to account for stretching, which is pretty amazing on FreeCAD's part. You'll notice when you use this feature here, create sheet metal wall from sketch, you have your flat pattern and your tangent edges on different planes. I've never been able to figure that out. I don't think it's supposed to be that way because it's not like that with the second method that I'm going to show you in this video. So ignore that. So why don't we go through another method of making sheet metal. This is actually my preferred method. I'm going to make another part entirely. From here, I'm going to start on the part design workbench, and you can use a lot of methods to create your initial solid. I'm going to go with the top plane, or the XY plane here. I'm doing a sketch. You can also go on the part workbench and do some kind of, additive rectangular prism. I don't use those pre-made solids very much. You might be able to do it a little bit faster than what I'm doing here. I'm going to go with something like 6 inches tall, Shift H for horizontal dimension. We're going to go with 18 inches wide. So again, Shift V to produce a vertical dimension, Shift H to produce a horizontal dimension, and we've added a symmetry constraint, and we're fully defined. So let's close that, and let's pad that. I'm going to do this a 1/16 of an inch, or 0.0625. And there we have a starting sheet metal piece. That looks quite thin. And 0.0625 inches instead of thou, and that way it's not hyper mega super thin, it's actually 1/16 of an inch. What I'm going to do here is go to the sheet metal workbench and add my bends. This is a really cool way of doing it. So as you can see, I've highlighted this edge. That's an edge that I want to insert a bend. So as I do, I select this button, extends wall from side face of metal sheet, and just like we've done in the last video, or the last example. And from here, let's go with, I have to highlight my bend. We're going to give this a length of, say, 3. In fact, I'm going to do something different. I'm going to go with 2 inches. I want my radius to be, that's about 40 thou. I think that's set to millimeter. Let's go with 62.5 thou, so it'll correlate with the thickness of our metal. And that should be good. So if you're comfortable with that, we're going to add one more here. Length, again, 3 inches. No, wait, I said 2. And we're already doing the correct radius. But that didn't seem to stick, so we're going to go 2 inches. Rebuild, there we go. Sometimes I have to rebuild these things, and I don't remember to do that. The next thing that I can do is I can select this line, hold Control, and select this other edge, and I can actually add a bend to both simultaneously. From here, highlight the bend. Our length is going to be, again, 2 inches. And that's looking pretty good. Okay, I will want to add some bends to kind of cover up these corners. Let's highlight these 2 edges. And when I insert bends and I make the radius, the constant radius, 62.5, you'll see that they go right into that wall, and that is not what we want. We want it to go on either side because it'd be very poor design and the blank would probably be useless otherwise. So I want to change a few parameters. The first one is I have material outside. I want to change that to offset. And I'm going to make this offset 0.07 inches, a little bit more than the thickness of my metal, so I have a reasonable gap to manufacture around. You'll notice that it puts it on the outside. And I might be fine with that, and I might actually want to change that to the inside. And if I want to change it to the inside, that is very reasonably easy. I have to stick a negative sign in front of my offset, and we automatically update to be on the other side. Now likewise here to here, again we'll add these I must have selected the wrong edge there. I'm going to get rid of this and try it once more here and here. That makes more sense, I think. So on this bend, there we go. We're going to make the radius 62.5 thou. We'll offset, and I'm going to update now. It looks like this radius might be a little bit off. So adjusting my bend 1, 62.5. Sometimes it can be kind of hard to keep all this consistent, but there we go. So I want to offset bend 4. And we're on bend type offset, so let's head on over to our offset and say 0.07. And that should put it on the outside when I rebuild, and it does. So I simply stick a negative in front of it. Now it can be tricky to not have some mitering on these edges, so I'm going to take bend 3 and I'm going to change my length to 0.5, and you can see they've should be getting a little bit longer when I rebuild. There we go. Let's go to this next bend, 004, 0.5, and there we go. We're a bit longer. And you know, we may want to unfold this just to make sure we still can, that there's no error stopping us. So I'm going to highlight my face, flatten, manual K factor, OK. And yes, indeed, we can generate a flat pattern, and it looks quite accurate. Now, this is something to know about this unfold and unfold sketch that's generated when we unfold. When I go to modify bend 004 and I change auto miter to false, and we go 45 and 45. So now we've mitered these edges, but the flat pattern does not update to reflect that. So you have to view this fold and unfold sketch as something that's non-parametric. If you want it to update, you simply delete these with the delete key, highlight a face, come over here, manual K factor, and now you have an updated flat pattern, or what I like to call the blank. So now that we've mitered those edges, choose bend 003, we'll do the same thing. We'll come in here, auto miter to false, and add in a 45 degree and recompute. There we have those tabs. Another tool that I have not mentioned is I can select, well, let's say I want to make this face a little bit longer and miter it to say 45 degrees. Well, if I try to do that, right, if I take my original bend and instead of 2 inches I say 3 inches, and I want to miter just that little part, then I'd say auto miter false, and then we come in here and say 45 degrees, and all of a sudden we've got a problem. It doesn't know where to stop. So there's a few things I can do. I can go to part design and add a chamfer there, or, and this is kind of my preference, let me take that out, let's say 0 degrees, and update it to get rid of that. My preference is to take this down back to 2 inches and use another tool that I haven't shown you how to use yet, and that is I can highlight an edge here and use this extend a face along normal, and on this I can change the length to something like 1 inch, rebuild, oh, my bad. Let me delete that. I did make a mistake. I highlight this face and extend by face. There we go. That's a lot better. I'm going to take this length to make it 1 inch. And now, when I look at this extend, it gives me a few options to add something like gaps. So that's how you would do gaps. But in addition to that, it makes it a lot easier for the mitering in that you can have a tangent line to reference off of should you need. So let's do that. Part design, chamfer, and we'll come over here, another chamfer, and we can make that something like 125 thou or 250 thou. I guess that's that's 250 feet for some reason. So let's turn that into inches. So you can do that. That looks like a relatively small chamfer. There you go, chamfer of 0.99 inches. It looks more like a tool tray that way. And of course, you can also edit by double-clicking. You can edit what face that you extend. This will probably break the chamfers, but if I click update, then I've added the extend face on this side. So that's how you would also change what face you're referencing when you do an extend. Oh, but the chamfer is carried over. We'll do the same thing on this side so that we're uniform. Going to Sheetmetal. We're going to go to extend a face, size 1 inch. Nope, but it looks like our chamfers ended up breaking because I'm seeing a rebuild error. So, in fact, I'm just going to delete the chamfer altogether and chamfer my two edges. Okay, so as you can see, part design parts that you add are applicable to the flat pattern. So if I add chamfers, they will show up in the flat pattern. Same thing with fillets. We're going to go with 0.99. And there you have that. Next thing I may want to do is add some holes, say some for like rivets. So we're going to create a sketch on this face. I'm going to change it to wireframe. I'm going to add 4 holes that would say rivet this thing together. Vertical with the V key, vertical. We're going to make sure that these are equal with the E key. Shift V for vertical dimension, and we'll give that something like 0.75. Shift R to add a radius, and we'll make that something like 0.0625, which I think goes to 1/8 of an inch. We're going to add in a horizontal with the H key, so these centers will be horizontal. I think I'll probably put a point on this axis so it's coincident up and down. I'll add in a symmetric constraint here, here, and here so that it positions these holes relative to each other. And then I simply add a height, Shift V for height. I know that I'm 2 inches tall, so if I make this 1 inch, then that should be in the center. Shift H for horizontal dimension. This should be the constraining dimension. We're going to make this about 2.75. That's not bad, but it feels off center, so I'm going to say something like 1.25. Okay, 1.125 to split the difference, and we're good. So we're going to close, pocket through all, and there you have holes for a rivet. The last thing I may want to do, when you work with sheet metal, especially if it's like plasma cut, you want to avoid sharp edges. And FreeCAD makes that pretty easy. I guess I have to select an edge first. That's an old SolidWorks habit. We can make something like 125 thou fillets, and this will smooth out our sharp edges. Okay, now with smoother edges, we can highlight a face, go to the Sheetmetal Workbench, flatten with the manual K factor, and we've produced, notice the fillets on our flat pattern, so we know that everything is completely up to date, and you can even see the holes for the rivets, though you may intend to drill them, after putting the part together, so you know that they'll fit perfectly. Another thing that would be pretty good to know is there's an alternative way to unbend some of these. If For instance, I can choose my original bend, and under unfold I can choose true, and it will unfold that bend. Now it can be, if you want to flatten the entire thing, you can. It could get a little bit tedious to go through every individual bend and unfold it. So what I would suggest doing is highlight your first bend here, hold Control and Shift, highlight your last bend, and coming to unfold and true. And the entire thing unfolds to match the sketch. So that's an alternative way to unfold everything, and especially if you want to see the solid body that you've made completely unfold, and you can always refold it as I have just done. Check out the All Visuals for You channel, as they also have a really great video on sheet metal that's a lot more concise than mine, and you could probably learn it faster since it's so to the point. I hope you've enjoyed this video, and if you have, please subscribe, and I'll see you in the next one.